Hello. Welcome to The History in the Shadow. Today we explore World 100 Most Talented Person Who Changed the World for the Rest if the History. Let's start per main story 100 Most Influential Scientists Who Shaped World History, Part 1. 1. Sir Isaac Newton. Birth. December 25, 1642, January 4, 1643. New Style. Woolsthorpe, Lincolnshire, England. Death. March 20th, March 31st, 1727. London. Known for the Newtonian revolution. Sir Isaac Newton was an English physicist and mathematician and was the culminating figure of the scientific revolution of the 17th century. In optics, his discovery of the composition of white light integrated the phenomena of colors into the science of light and laid the foundation for modern physical optics. In mechanics, his three laws of motion, the basic principles of modern physics, resulted in the formulation of the law of universal gravitation. In mathematics, he was the original discoverer of the infinitesimal calculus. Newton's Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, 1687, was one of the most important single works in the history of modern science. 2. Albert Einstein. Birth. March 14, 1879. Ulm, Württemberg, Germany. Death. April 18, 1955. Princeton, New Jersey, U.S. Known for 20th century science. Albert Einstein was a German-born physicist who developed the special and general theories of relativity and won the Nobel Prize for Physics in 1921 for his explanation of the photoelectric effect. Einstein is generally considered the most influential physicist of the 20th century. 3. Niels Bohr. Birth. October 7, 1885. Copenhagen, Denmark. Death. November 18, 1962. Copenhagen. Known for the atom. Niels Henrik David Bohr was a Danish physicist who is generally regarded as one of the foremost physicists of the 20th century. He was the first to apply the quantum concept, which restricts the energy of a system to certain discrete values, to the problem of atomic and molecular structure. For that work, he received the Nobel Prize for Physics in 1922. His manifold roles in the origins and development of quantum physics may be his most important contribution, but through his long career his involvements were substantially broader, both inside and outside the world of physics. 4. Charles Darwin. Birth. February 12, 1809. Shrewsbury, Shropshire, England. Death. April 19, 1882. Down, Kent. Known for evolution. Charles Robert Darwin was an English naturalist whose scientific theory of evolution by natural selection became the foundation of modern evolutionary studies. An affable country gentleman, Darwin at first shocked religious Victorian society by suggesting that animals and humans shared a common ancestry. However, his non-religious biology appealed to the rising class of professional scientists, and by the time of his death evolutionary imagery had spread through all of science, literature, and politics. Darwin, himself an agnostic, was accorded the ultimate British accolade of burial in Westminster Abbey, London. 5. Louis Pasteur. Birth. December 27, 1822. Dole, France. Death. September 28, 1895. St. Cloud, near Paris. Known for the germ theory of disease. Louis Pasteur was a French chemist and microbiologist who was one of the most important founders of medical microbiology. Pasteur's contributions to science, technology, and medicine are nearly without precedent. He pioneered the study of molecular asymmetry, discovered that microorganisms cause fermentation and disease, originated the process of pasteurization, saved the beer, wine, and silk industries in France, and developed vaccines against anthrax and rabies. 6. Sigmund Freud. Birth. May 6, 1856. Freiburg, Moravia, Austrian Empire. Now Freiburg, Czech Republic. Death. September 23, 1939. London, England. Known for Psychology of the Unconscious. 7. Galileo Galilei. Birth. February 15, 1564. Pisa, Italy. Death. January 8, 1642. Arcetri, near Florence. Known for the new science. Galileo was an Italian natural philosopher, astronomer, and mathematician who made fundamental contributions to the sciences of motion, astronomy, and strength of materials and to the development of the scientific method. His formulation of circular inertia, the law of falling bodies, and parabolic trajectories marked the beginning of a fundamental change in the study of motion. His insistence that the book of nature was written in the language of mathematics changed natural philosophy from a verbal, qualitative account to a mathematical one in which experimentation became a recognized method for discovering the facts of nature. Finally, his discoveries with the telescope revolutionized astronomy and paved the way for the acceptance of the Copernican heliocentric system, but his advocacy of that system eventually resulted in an inquisition process against him. Sigmund Freud was an Austrian neurologist and the founder of psychoanalysis, a clinical method for treating psychopathology through dialogue between a patient and a psychoanalyst. 3. If I have seen further, it is by standing on the shoulders of giants. Isaac Newton's 3 laws of motion. Every object in a state of rest will remain in that state of rest unless an external force acts on it. Force equals mass times acceleration. For every action there is an equal and opposite reaction. Newton's law of universal gravitation. Fg equals gmm are 2 where Fg denote the gravitational force acting between two objects. M and m, the masses of the objects, are the distance between the centers of their masses, and g the gravitational constant. Logic will get you from A to Z. Imagination will get you everywhere. Albert Einstein's mass-energy relation, energy equals mass times speed of light. 2 Einstein's special relativity equations. Relativistic mass equals rest mass square root 1 minus velocity. 2 speed of light. 2 contracted length equals original length times square root 1 minus velocity. 2 speed of light. 2 dilated time equals stationary time square root 1 minus velocity. 2 speed of light. 2 Einstein's photoelectric equation. Energy of photon equals minimum energy needed to remove an electron. Einstein's general theory of relativity. Strain is proportional to stress plus spacetime. Curvature is proportional to mass energy stress. Maximum kinetic energy of the emitted electron. Curvature from stuff in spacetime. Mass energy stress plus curvature of spacetime itself equals. Those who are not shocked when they first come across quantum theory cannot possibly have understood it. Niels Bohr in 1911, fresh from completion of his PhD, the young Danish physicist Niels Bohr left Denmark on a foreign scholarship headed for the Cavendish Laboratory in Cambridge to work under J.J. Thomson on the structure of atomic systems. At the time, Bohr began to put forth the idea that since light could no longer be treated as continuously propagating waves, but instead as discrete energy packets, as articulated by Max Planck and Albert Einstein, why should the classical Newtonian mechanics on which Thomson's model was based hold true? It seemed to Bohr that the atomic model should be modified in a similar way. If electromagnetic energy is quantized, i.e. restricted to take on only integer values of h upsilon, where upsilon is the frequency of light, then it seemed reasonable that the mechanical energy associated with the energy of atomic electrons is also quantized. However, Bohr's still somewhat vague ideas were not well received by Thomson, and Bohr decided to move from Cambridge after his first year to a place where his concepts about quantization of electronic motion in atoms would meet less opposition. He chose the University of Manchester, where the chair of physics was held by Ernest Rutherford. While in Manchester, Bohr learned about the nuclear model of the atom proposed by Rutherford. To overcome the difficulty associated with the classical collapse of the electron into the nucleus, Bohr proposed that the orbiting electron could only exist in certain special states of motion, called stationary states, in which no electromagnetic radiation was emitted. In these states, the angular momentum of the electron L takes on integer values of Planck's constant divided by 2 pi, denoted by equals h, pronounced h-bar. In these stationary states, the electron angular momentum 2 pi can take on values h, 2h, 3h, but never non-integer values. This is known as quantization of angular momentum, and was one of Bohr's key hypotheses. He imagined the atom as consisting of electron waves of wavelength lambda equals hmv equals hp endlessly circling atomic nuclei. In his picture, only orbits with circumferences corresponding to an integral multiple of electron wavelengths could survive without destructive interference, i.e., r equals nmv could survive without destructive interference. For circular orbits, the position vector of the electron r is always perpendicular to its linear momentum p. The angular momentum L has magnitude mvr in this case. Thus Bohr's postulate of quantized angular momentum is equivalent to mvr equals n, where n is a positive integer called principal quantum number. It tells us what energy level the electron occupies. You cannot teach a man anything. You can only help him find it within himself. Galileo kinematic equations. Final velocity equals initial velocity plus acceleration times time. Displacement equals initial velocity times time plus 1 acceleration times time. 2. Final velocity. 2 equals initial velocity. 2 plus 2 acceleration times displacement. In our acquisition of knowledge of the universe, that which renovates the quest is nothing more nor less than complete innocence. In this state of complete innocence, we receive everything from the moment of our birth. Although so often the object of our contempt and private fears, it is always in us. It alone can unite humility with boldness to allow us to penetrate to the heart of things or allow things to enter us and take in possession of us. This unique power is not a privilege of exceptional talents, persons of incredible brain power, better able to manipulate, with dexterity and ease, an enormous mass of ideas and specialized skills. Such gifts are valuable and undoubtedly worthy of envy from those who, like myself, were not so endowed at birth, far beyond the ordinary. Yet it is not these gifts, nor the most determined ambition and willpower, that enables one to surmount the invisible yet formidable boundaries that encircle our universe. Only innocence can surmount them, which mere knowledge doesn't even take into account. In those moments when we find ourselves able to listen to things, intensely absorbed in child's play. Alexander Grothendieck, a mathematician who was the focal point in the launching of the modern theory of algebraic geometry. James Hillman was an eminent American therapist. He was the principal director of the Jung Institute in Zurich and established a development toward prototype brain research which arose out of the Jungian convention. No fairer destiny could be allotted to any physical theory than that it should of itself point out the way to the introduction of a more comprehensive theory, in which it lives on as a limiting case. Albert Einstein, one of the best uncelebrated logical masters ever, was the German mathematician and physicist Amalie Emmy Noether. Despite the fact that she endured segregation all through her splendid vocation, her associates perceived her extraordinary virtuoso. It is hard to exaggerate the significance of her commitments to extract variable-based math and hypothetical physical science. Noether's hypothesis, for instance, which states that given a physical system, for every infinitesimal symmetry, there is a corresponding law of symmetry minus associates evenness and preservation laws, is a significant foundation of current hypothetical material science. Additionally, her authority of present-day polynomial math drove the mathematician Irving Kaplansky to comment, "It most likely isn't a lot of a misrepresentation to call her the mother of current polynomial math. When I speak about computer programming as an art, I am thinking primarily of it as an art form in an aesthetic sense. The chief goal of my work as an educator and author is to help people learn how to write beautiful programs. My feeling is that when we prepare a program, it can be like composing poetry or music. As the Soviet computer scientist Andrei Urshov has said, programming can give us both intellectual and emotional satisfaction because it is a real achievement to master complexity and to establish a system of consistent rules." Donald Knuth, an American computer scientist, mathematician, and professor emeritus at Stanford University. Letter from Dutch post-impressionist painter Vincent Willem van Gogh to his brother Theo. What am I in the eyes of most people? A nonentity, an eccentric, or an unpleasant person? Somebody who has no position in society and will never have. In short, the lowest of the low. All right, then, even if that were absolutely true, then I should one day like to show by my work what such an eccentric, such a nobody, has in his heart. That is my ambition, based less on resentment than on love in spite of everything, based more on a feeling of serenity than on passion. Though I am often in the depths of misery, there is still calmness, pure harmony, and music inside me. I see paintings or drawings in the poorest cottages, in the dirtiest corners, and my mind is driven towards these things with an irresistible momentum. You know that I write slowly. This is chiefly because I am never satisfied until I have said as much as possible in a few words, and writing briefly takes far more time than writing at length. Carl Friedrich Gauss, in a 1929 meeting, German-born theoretical physicist Albert Einstein was inquired, how could he get his thoughts? His answer was, I'm sufficient of a craftsman to draw unreservedly on my creative mind. Creative mind is a higher priority than information. Information is restricted. Creative mind encompasses the world. In the spring of 1955, not well before he passed on April 18th, German-born theoretical physicist Albert Einstein entered the medical clinic since his heart was starting to fall flat. His companion Dutch-American physicist and science historian Abraham Pius described, a few days before Einstein died on April 15th, he called his secretary. He needed his wellspring pen, his glasses, and his most recent piece of notes. What's more, Einstein obviously realized that his time was approaching to go. Yet he needed a mini-computer. What's more, he plunked down and started to ascertain. That is a story that makes you shiver. It makes me shiver. He realized he would not see whatever would emerge from these figurings via accomplishment. It didn't make a difference to him. Maria Gaetana Agnesi was an Italian mathematician, philosopher, theologian, and humanitarian. She was the first woman to write a mathematics handbook on both integral and differential calculus and the first woman appointed as a mathematics professor at a university. 8. Antoine-Laurent Lavoisier birth. August 26, 1743, Paris, France. Death. May 8, 1794, Paris. Known for the revolution in chemistry, Antoine-Laurent Lavoisier was a prominent French chemist and leading figure in the 18th century chemical revolution, who developed an experimentally based theory of the chemical reactivity of oxygen and co-authored the modern system for naming chemical substances. Having also served as a leading financier and public administrator before the French Revolution, he was executed with other financiers during the Revolutionary Terror. 9. Johannes Kepler birth. December 27, 1571, Walderstadt, Württemberg, Germany. Death. November 15, 1630, Regensburg. Known for motion of the planets, Johannes Kepler was a German astronomer who discovered three major laws of planetary motion, conventionally designated as follows. 1. The planets move in elliptical orbits with the Sun at one focus. 2. The time necessary to traverse any arc of a planetary orbit is proportional to the area of the sector between the central body and that arc, the area law. And 3. There is an exact relationship between the squares of the planets' periodic times and the cubes of the radii of their orbits, the harmonic law. Kepler himself did not call these discoveries laws, as would become customary after Isaac Newton derived them from a new and quite different set of general physical principles. He regarded them as celestial harmonies that reflected God's design for the universe. Kepler's discoveries turned Nicholas Copernicus's sun-centered system into a dynamic universe, with the sun actively pushing the planets around in non-circular orbits. And it was Kepler's notion of a physical astronomy that fixed a new problematic for other important 17th-century world system builders, the most famous of whom was Newton. 10. Nicholas Copernicus birth. February 19, 1473, Torunia, Poland. Death. May 24, 1543, Frauenburg, East Prussia. Now from Bork, Poland. Known for the heliocentric universe, Nicholas Copernicus was a Polish astronomer who proposed that the planets have the Sun as the fixed point to which their motions are to be referred, that Earth is a planet which, besides orbiting the Sun annually, also turns once daily on its own axis, and that very slow long-term changes in the direction of this axis account for the precession of the equinoxes. This representation of the heavens is usually called the heliocentric, or sun-centered, system, derived from the Greek helios, meaning sun. Copernicus's theory had important consequences for later thinkers of the scientific revolution, including such major figures as Galileo, Kepler, Descartes, and Newton. Copernicus probably hit upon his main idea sometime between 1508 and 1514, and during those years he wrote a manuscript usually called the Commentarialus, Little Commentary. However, the book that contains the final version of his theory, De Revolutionibus Orbium Coelestium Libri 6 books concerning the revolutions of the heavenly orbs, did not appear in print until 1543, the year of his death. 11. Michael Faraday birth. September 22, 1791, Newington, Surrey, England. Death. August 25, 1867, Hampton Court. Known for the classical field theory. 12. James Clerk Maxwell birth. June 13, 1831, Edinburgh, Scotland. Death. November 5, 1879, Cambridge, Cambridgeshire, England. Known for The electromagnetic field. Michael Faraday was an English physicist and chemist whose many experiments contributed greatly to the understanding of electromagnetism. James Clerk Maxwell was a Scottish physicist best known for his formulation of electromagnetic theory. He is regarded by most modern physicists as the scientist of the 19th century who had the greatest influence on 20th century physics, and he is ranked with Sir Isaac Newton and Albert Einstein for the fundamental nature of his contributions. In 1931, on the 100th anniversary of Maxwell's birth, Einstein described the change in the conception of reality in physics that resulted from Maxwell's work as the most profound and the most fruitful that physics has experienced since the time of Newton. 13. Claude Bernard birth. July 12, 1813. Saint Julian death. February 10, 1878. Paris known for. The founding of modern physiology. Claude Bernard was a French physiologist known chiefly for his discoveries concerning the role of the pancreas in digestion, the glycogenic function of the liver, and the regulation of the blood supply by the vasomotor nerves. On a broader stage, Bernard played a role in establishing the principles of experimentation in the life sciences, advancing beyond the vitalism and indeterminism of earlier physiologists to become one of the founders of experimental medicine. His most seminal contribution was his concept of the internal environment of the organism, which led to the present understanding of homeostasis, i.e., the self-regulation of vital processes. 14. Franz Boas birth. July 9, 1858. Minden, Westphalia, Germany death. December 21, 1942. New York, U.S. known for. Modern anthropology. Franz Boas was a German-born American anthropologist of the late 19th and early 20th centuries, the founder of the relativistic, culture-centered school of American anthropology that became dominant in the 20th century. During his tenure at Columbia University in New York City, 1899 to 1942, he developed one of the foremost departments of anthropology in the United States. Boas was a specialist in North American Indian cultures and languages, but he was, in addition, the organizer of a profession and the great teacher of a number of scientists who developed anthropology in the United States, including A.L. Kroeber, Ruth Benedict, Margaret Mead, Melville Herskovits, and Edward Sapir. 15. Werner Heisenberg birth. December 1901, Würzburg, Bavaria, German Empire death. February 1, 1976, Munich, Bavaria, West Germany known for. Quantum theory. Werner Karl Heisenberg was a German physicist and philosopher who discovered a way to formulate quantum mechanics in terms of matrices. For that discovery, he was awarded the Nobel Prize for Physics for 1932. In 1927, he published his uncertainty principle, upon which he built his philosophy and for which he is best known. He also made important contributions to the theories of the hydrodynamics of turbulent flows, the atomic nucleus, ferromagnetism, cosmic rays, and subatomic particles, and he was instrumental in planning the first West German nuclear reactor at Karlsruhe, together with a research reactor in Munich in 1957. Considerable controversy surrounds his work on atomic research during World War II. 16. Linus Pauling birth. February 28, 1901, Portland, Oregon, U.S. Death. August 19, 1994, Big Sur, California known for. 20th century chemistry. Linus Carl Pauling was an American theoretical physical chemist who became the only person to have won 2 unshared Nobel Prizes. His first prize, 1954, was awarded for research into the nature of the chemical bond and its use in elucidating molecular structure. The second, 1962, recognized his efforts to ban the testing of nuclear weapons. 17. Erwin Schrödinger birth. August 12, 1887, Vienna, Austria death. January 4, 1961, Vienna known for. Wave mechanics. Erwin Schrödinger was an Austrian theoretical physicist who contributed to the wave theory of matter and to other fundamentals of quantum mechanics. He shared the 1933 Nobel Prize for Physics with British physicist P.A.M. Dirac. 18. John James Audubon birth. April 26, 1785, Les Cayes, Saint-Domingue, West Indies now in Haiti death. January 27, 1851, New York, U.S. Known for drawings and paintings of North American birds. John James Audubon was an ornithologist, artist, and naturalist who became particularly well known for his drawings and paintings of North American birds. 19. Ernest Rutherford birth. August 30, 1871, Spring Grove, NZ Death. October 19, 1937, Cambridge, Cambridgeshire, England. Known for the structure of the atom. 8 Ernest Rutherford was a New Zealand-born British physicist considered the greatest experimentalist since Michael Faraday, 1791 to 1867. Rutherford was the central figure in the study of radioactivity, and with his concept of the nuclear atom, he led the exploration of nuclear physics. He won the Nobel Prize for Chemistry in 1908, was president of the Royal Society, 1925 to 30, and the British Association for the Advancement of Science, 1923, was conferred the Order of Merit in 1925, and was raised to the peerage as Lord Rutherford of Nelson in 1931. 20 Paul Adrian Maurice Dirac. Birth: August 8, 1902, Bristol, Gloucestershire, England. Death: October 20, 1984, Tallahassee, Florida, USA. Known for quantum electrodynamics. Paul Adrian Maurice Dirac was an English theoretical physicist who was one of the founders of quantum mechanics and quantum electrodynamics. Dirac is most famous for his 1928 relativistic quantum theory of the electron and his prediction of the existence of antiparticles. In 1933, he shared the Nobel Prize for Physics with the Austrian physicist Erwin Schrödinger. 21 Andreas Vesalius. Birth: December 1514, Brussels. Now in Belgium. Death: June 1564, Island of Zacynthus, Republic of Venice. Now in Greece. Known for the new anatomy. Andreas Vesalius was a Renaissance physician who revolutionized the study of biology and the practice of medicine by his careful description of the anatomy of the human body. Basing his observations on dissections he made himself, he wrote and illustrated the first comprehensive textbook of anatomy. The history of astronomy is a history of receding horizons. Edwin Powell. Hubble's law, where V equals dd/dt equals hdv is the observed velocity of the galaxy away from us, usually in km/sech is Hubble's constant, in km/sec/mpcd is the distance to the galaxy, and MPC science cannot solve the ultimate mystery of nature. And that is because, in the last analysis, we ourselves are a part of the mystery that we are trying to solve. Planck's quantum theory, E equals h upsilon a max Planck, where h denote the Planck's constant, 6.6260695 times 10⁻34 Js. Upsilon the frequency, and E the energy of an electromagnetic radiation. Not only is the universe stranger than we think, it is stranger than we can think. Werner Heisenberg's uncertainty principle. Uncertainty in position times uncertainty of momentum greater than or equal to 4 pi. Uncertainty of energy times uncertainty in time greater than or equal to 4 pi. The history of science shows that the progress of science has constantly been hampered by the tyrannical influence of certain conceptions that finally came to be considered as dogma. For this reason, it is proper to submit periodically to a very searching examination principles that we have come to assume without any more discussion. A Lewis de Broglie equation. Wavelength equals Planck's constant momentum. There are two possible outcomes. If the result confirms the hypothesis, then you've made a measurement. If the result is contrary to the hypothesis, then you've made a discovery. A Enrico Fermi temperature equals Fermi energy Boltzmann constant Fermi momentum equals square root 2 times particle mass times Fermi energy Fermi velocity equals Fermi momentum particle mass Fermi momentum equals Planck's constant 2 pi times Fermi wave vector. Nothing takes place in the world whose meaning is not that of some maximum or minimum. Euler's identity. EI pi plus 1 is equal to 0. A Leonhard Euler. You have no responsibility to live up to what other people think you ought to accomplish. I have no responsibility to be like they expect me to be. It's their mistake, not my failing. Minus Richard P. Feynman. Quite possibly the most strange figures throughout the entire existence of mathematical physics is George Green. He was a dough puncher and mill operator who, with little formal education, authored an important treatise on mathematical physics. He was first to attempt to devise a theory of electricity and magnetism. This work proclaimed the start of modern mathematical physics in Great Britain. Constance Bowman Reid wrote in her superb memoir of German mathematician David Hilbert, one of the most influential mathematicians of the 19th and early 20th centuries. Hilbert had no tolerance with numerical talks, which filled the understudies with realities, however, didn't show them how to outline an issue and address it. He regularly used to disclose to them that an ideal definition of an issue is as of now a large portion of its answer. Two sentences stand out on American theoretical physicist Richard Feynman's writing board at his time of death. What I cannot make, I don't understand. Know how to illuminate each issue that has been solved. Julian Schwinger already understands 90 of physics. The remaining 10 should only take a few days. Feynman could do anything at all. At one time, the most important group in our division was concerned with calculating machines. The two men I had put in charge of these computers just played with them, and they never gave us the answers we wanted. I asked Feynman to take over. As soon as he got in there, we got answers every week. Lots of them and very accurate. He always knew what was needed, and he always knew what had to be done to get it. I should mention that the computer had arrived in boxes, about 10 boxes for each. Feynman and one of the former group leaders put the machines together. Later we got some professionals from IBM who said, "This has never been done before. I have never seen laymen put together one of these machines, and it's perfect." Minus Hans Albrecht Bethe, a German-American nuclear physicist who made important contributions to astrophysics, quantum electrodynamics, and solid-state physics, and who won the 1967 Nobel Prize in Physics for his work on the theory of stellar nucleosynthesis. The Indian mathematician and hypothetical physicist Satyendra Nath Bose, 1894 to 1974, is well known for his collaboration with German physicist Albert Einstein in developing a theory regarding the gas-like qualities of electromagnetic radiation, Bose-Einstein statistics. But Bose's judgment skills weren't confined to hypothetical material science. His interface included test material science, chemistry, science, mineralogy, reasoning, expressions, writing, and music. He too adored verse, chess, and cats. Euler was the most prolific writer of mathematics in history of the subject. He wrote mathematics incessantly with the effortless ease and fluency that a skilled conversationalist exhibits when speaking. It is said that he would dash off a mathematical paper in the scant half-hour between the first and second call to dinner. As soon as Euler finished a paper, he would put it on top of a growing stack that was awaiting the printer. When material was needed to fill the Academy's transactions, the printer would grab a sheaf from the top of the pile. A monumental edition of Euler's complete works was initiated in 1909 and was planned to run into 73 volumes. But the later discovery of overlooked material will considerably increase this number. Minus Howard Whitley Eves, an American mathematician, known for his work in geometry and the history of mathematics, when Paul Adrien Maurice Dirac, an English theoretical physicist who is regarded as one of the most significant physicists of the 20th century, was creating quantum mechanics, a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. He presented an unrigorous numerical work, the Dirac delta function. Extreme Dirac recognized that the work was unrigorous. He famous it might be utilized, as in spite of the fact that it was an appropriate work for all intents and purposes, all purposes in quantum mechanics. Later, he commented that his ponder of designing driven him to it. "I think it was that sort of preparing that gave me the thought of the delta work, since once you think of load in building structures, now and then you have got a distributed load, and now and then you've got a concentrated stack at the point. It is the same whether you have got a concentrated stack or a dispersed one, but you employ to some degree distinctive conditions within the two cases. I tease as it were to bind together these two things which sort of driven to the delta function. I never come across one of Laplace's. Thus it plainly appears without feeling that I have hours of hard work before me to fill up the chasm and find out and show how it plainly appears." Minus Nathaniel Bowditch, an early American mathematician remembered for his work on ocean navigation. There are many categories of scientists. Those of second or third rank never get very far. Then there is the first rank, those who make important discoveries. But then there are the geniuses like Galileo and Newton. Majorana was one of these. Minus Enrico Fermi, the creator of the world's first nuclear reactor, the Chicago Pile 1, my intuition was not strong enough in the field of mathematics in order to differentiate clearly the fundamentally important from the rest of the more or less dispensable erudition. Beyond this, however, my interest in the knowledge of nature was also unqualifiedly stronger. In this field, I soon learned to scent out that which was able to lead to fundamentals and to turn aside from the multitude of things which clutter up the mind and divert it from the essential. Minus Albert Einstein, Autobiographical Notes. This brief work is the closest Albert Einstein ever came to composing a personal history. In spite of the fact that an awfully individual account, it is simply concerned with the advancement of his thoughts, saying small approximately his private life or almost the world-shaking occasions through which he lived. Frank Nelson Cole, September 20, 1861 to May 26, 1926, was an American mathematician, born in Ashland, Massachusetts, and educated at Harvard, where he lectured on mathematics from 1885 to 1887. Later, he was employed at the University of Michigan and Columbia University. Professor Cole became secretary of the American Mathematical Society in 1895 and an editor of its bulletin in 1897. Cole published a number of important papers, including the diurnal variation of barometric pressure, 1892. In 1893 in Chicago, his paper on a certain simple group was read, but not by him, at the International Mathematical Congress held in connection with the World's Columbian Exposition. On October 31, 1903, Cole famously made a presentation to a meeting of the American Mathematical Society where he identified the factors of the Mersenne number 267-1, or M67. Edouard Lucas had demonstrated in 1876 that M67 must have factors, i.e. is not prime, but he was unable to determine what those factors were. During Cole's so-called lecture, he approached the chalkboard and in complete silence proceeded to calculate the value of M67, with the result being 147,573,952,589,676,412,927. Cole then moved to the other side of the board and wrote 193,707,721 times 761,838,257,287, and worked through the tedious calculations by hand. Upon completing the multiplication and demonstrating that the result equaled M67, Cole returned to his seat, not having uttered a word during the hour-long presentation. His audience greeted the presentation with a standing ovation. Cole later admitted that finding the factors had taken 3 years of Sundays. Cole died alone in New York City, aged 64. The American Mathematical Society's Cole Prize was named in his honor. Though I knew Einstein for 2 or 3 decades, it was only in the last decade of his life that we were close colleagues and something of friends. But I thought that it might be useful because I am sure that it is not too soon, and for our generation perhaps almost too late, to start to dispel the clouds of myth and to see the great mountain peak that these clouds hide. As always, the myth has its charms, but the truth is far more beautiful. G. Robert Oppenheimer 22 Tycho Brahe birth, December 14, 1546, Knudstrup, Scania, Denmark death, October 24, 1601, Prague known for. The new astronomy Tycho Brahe was a Danish astronomer whose work in developing astronomical instruments and in measuring and fixing the positions of stars paved the way for future discoveries. His observations, the most accurate possible before the invention of the telescope, included a comprehensive study of the solar system and accurate positions of more than 777 fixed stars. 23 Comte de Buffon birth, September 7, 1707, Montbard, Burgundy, France death, April 16, 1788, Paris, France known for. L'Histoire naturelle Comte de Buffon was a French naturalist, mathematician, cosmologist, and encyclopedist. His works influenced the next 2 generations of naturalists, including Jean-Baptiste Lamarck and Georges Cuvier. Buffon published 36 quarto volumes of his Histoire naturelle during his lifetime, with additional volumes based on his notes and further research being published in the 2 decades following his death. 24 Ludwig Boltzmann birth, February 20, 1844, Vienna, Austrian Empire, present-day Austria, death. September 5, 1906, Tybien near Trieste, Austria-Hungary present-day Duino, Italy known for. Thermodynamics 10 Ludwig Eduard Boltzmann was an Austrian physicist whose greatest achievement was in the development of statistical mechanics, which explains and predicts how the properties of atoms, such as mass, charge, and structure, determine the visible properties of matter, such as viscosity, thermal conductivity, and diffusion. 25 Max Planck birth. April 23, 1858, Kiel, Schleswig, Germany. Death. October 4, 1947, Göttingen, West Germany. Known for. The quantum max. Carl Ernst Ludwig Planck was a German theoretical physicist who originated quantum theory, which won him the Nobel Prize for Physics in 1918. 26 Marie Curie birth. November 7, 1867, Warsaw, Poland, Russian Empire. Death. July 4, 1934, near Salanches, France. Known for. Radioactivity. Marie Curie was a Polish-born French physicist, famous for her work on radioactivity and twice a winner of the Nobel Prize. With Henri Becquerel and her husband Pierre Curie, she was awarded the 1903 Nobel Prize for Physics. She was the sole winner of the 1911 Nobel Prize for Chemistry. She was the first woman to win a Nobel Prize, and she is the only woman to win the award in 2 different fields. 27 Sir William Herschel birth. November 15, 1738, Hanover, Germany. Death. August 25, 1822, Slough, Buckinghamshire, England. Known for. Sidereal astronomy. Sir William Frederick Herschel was a German-born British astronomer, the founder of sidereal astronomy for the systematic observation of the heavens. He discovered the planet Uranus, hypothesized that nebulae are composed of stars, and developed a theory of stellar evolution. He was knighted in 1816. 28 Charles Lyell birth. November 14, 1797, Kinnerty, Forfarshire, Scotland. Death. February 22, 1875, London, England. Known for. Modern geology. Sir Charles Lyell, Baronet, was a Scottish geologist largely responsible for the general acceptance of the view that all features of the Earth's surface are produced by physical, chemical, and biological processes through long periods of geological time. The concept was called uniformitarianism, initially set forth by James Hutton. Lyell's achievements laid the foundations for evolutionary biology, as well as for an understanding of the Earth's development. He was knighted in 1848 and made a baronet in 1864. 29 Pierre Simon de Laplace birth. March 23, 1749, Beaumont-en-Auge, Normandy, France. Death. March 5, 1827, Paris. Known for. Black hole. Nebular hypothesis of the origin of the solar system. Pierre-Simon de Laplace was a French scholar and polymath whose work was important to the development of engineering, mathematics, statistics, physics, astronomy, and philosophy. He summarized and extended the work of his predecessors in his 5-volume Mécanique céleste, Celestial Mechanics. This work translated the geometric study of classical mechanics to one based on calculus, opening up a broader range of problems. In statistics, the Bayesian interpretation of probability was developed mainly by Laplace. Laplace is remembered as one of the greatest scientists of all time. Sometimes referred to as the French Newton or Newton of France, he has been described as possessing a phenomenal natural mathematical faculty superior to that of any of his contemporaries. 30 Edwin Powell Hubble birth. November 20, 1889, Marshfield, Missouri, U.S. Death. September 28, 1953, San Marino, California. Known for. Extragalactic astronomy. Edwin Powell Hubble was an American astronomer who played a crucial role in establishing the field of extragalactic astronomy and is generally regarded as the leading observational cosmologist of the 20th century. 31 Joseph J. Thomson birth. December 18, 1856, Cheetham Hill, Manchester, Lancashire, England, United Kingdom. Death. August 30, 1940, Cambridge, Cambridgeshire, England, UK. Known for. The discovery of the electron. Sir Joseph John Thomson was an English physicist who helped revolutionize the knowledge of atomic structure by his discovery of the electron, 1897. He received the Nobel Prize for Physics in 1906 and was knighted in 1908. 32 Max Born birth. December 11, 1882, Breslau, German Empire. Death. January 5, 1970, Göttingen, West Germany. Known for. Quantum mechanics. Max Born was a German physicist who shared the Nobel Prize for Physics in 1954 with Walther Botha for his probabilistic interpretation of quantum mechanics. 33 Francis Harry Compton Crick birth. June 8, 1916, Northampton, Northamptonshire, England death. July 28, 2004, San Diego, California, U.S. Known for molecular biology. Francis Harry Compton Crick was a British biophysicist who, with James Watson and Maurice Wilkins, received the 1962 Nobel Prize for Physiology or Medicine for their determination of the molecular structure of deoxyribonucleic acid, DNA, the chemical substance ultimately responsible for hereditary control of life functions. This accomplishment became a cornerstone of genetics and was widely regarded as one of the most important discoveries of 20th century biology. 34 Enrico Fermi birth. September 29, 1901, Rome, Italy death. November 28, 1954, Chicago, Illinois, U.S. Known for statistical mechanics. Enrico Fermi was an Italian-born American scientist who was one of the chief architects of the nuclear age. He developed the mathematical statistics required to clarify a large class of subatomic phenomena, explored nuclear transformations caused by neutrons, and directed the first controlled chain reaction involving nuclear fission. He was awarded the 1938 Nobel Prize for Physics, and the Enrico Fermi Award of the U.S. Department of Energy is given in his honor. Fermilab, the National Accelerator Laboratory in Illinois, is named for him, as is fermium element number 100. 35 Leonhard Euler birth. April 15, 1707, Basel, Switzerland death. September 18, 1783, St. Petersburg, Russian Empire. Known for 18th century mathematics. Leonhard Euler was a Swiss mathematician and physicist, one of the founders of pure mathematics. He not only made decisive and formative contributions to the subjects of geometry, calculus, mechanics, and number theory, but also developed methods for solving problems in observational astronomy and demonstrated useful applications of mathematics in technology and public affairs. 36 Justus Liebig birth. May 12, 1803, Darmstadt, Grand Duchy of Hesse death. April 18, 1873, Munich, German Empire. Known for 19th century chemistry. Justus Freiherr von Liebig was a German scientist who made major contributions to agricultural and biological chemistry, and is considered one of the principal founders of organic chemistry. As a professor at the University of Gießen, he devised the modern laboratory-oriented teaching method, and for such innovations, he is regarded as one of the greatest chemistry teachers of all time. He has been described as the father of the fertilizer industry, for his emphasis on nitrogen and trace minerals as essential plant nutrients, and his formulation of the law of the minimum, which described how plant growth relied on the scarcest nutrient resource, rather than the total amount of resources available. He also developed a manufacturing process for beef extracts, and with his consent a company, called Liebig Extract of Meat Company, was founded to exploit the concept. It later introduced the OXO brand beef bouillon cube. He popularized an earlier invention for condensing vapors, which came to be known as the Liebig condenser. 37 Arthur Stanley Eddington birth. December 28, 1882, Kendal, Westmoreland, England death. November 22, 1944, Cambridge, Cambridgeshire, England. Known for modern astronomy. Sir Arthur Stanley Eddington was an English astronomer, physicist, and mathematician who did his greatest work in astrophysics, investigating the motion, internal structure, and evolution of stars. He also was the first expositor of the theory of relativity in the English language. 38 William Harvey birth. April 1, 1578, Folkestone, Kent, England death. June 3, 1657, London. Known for circulation of the blood. William Harvey was an English physician who was the first to recognize the full circulation of the blood in the human body and to provide experiments and arguments to support this idea. 39 Marcello Malpighi birth. 1628 death. 1694 Known for microscopic anatomy. Marcello Malpighi was an Italian physician and biologist who, in developing experimental methods to study living things, founded the science of microscopic anatomy. After Malpighi's researches, microscopic anatomy became a prerequisite for advances in the fields of physiology, embryology, and practical medicine. 40 Christian Huygens birth. 1629 death. 1695 Known for the wave theory of light. Christian Huygens was a Dutch mathematician, astronomer and physicist, who founded the wave theory of light, discovered the true shape of the rings of Saturn, and made original contributions to the science of dynamics, the study of the action of forces on bodies. 41 Johann Carl Friedrich Gauss birth. April 30th, 1777, Brunswick, Duchy of Brunswick-Wolfenbüttel, Holy Roman Empire death. February 23, 1855, Göttingen, Kingdom of Hanover known for number theory, algebra, statistics, analysis, differential geometry, geodesy, geophysics, mechanics, electrostatics, astronomy, matrix theory and optics. Johann Carl Friedrich was a German mathematician and physicist who made significant contributions to many fields in mathematics and science. Sometimes referred to as the Princeps Mathematicorum, Latin for the foremost of mathematicians, and the greatest mathematician since antiquity, Gauss had an exceptional influence in many fields of mathematics and science, and is ranked among history's most influential mathematicians. 42 Albrecht von Haller birth. October 16, 1708, Bern, Swiss Confederacy death. December 12, 1777, Bern, Swiss Confederacy known for 18th century medicine. Albrecht von Haller was a Swiss biologist, the father of experimental physiology, who made prolific contributions to physiology, anatomy, botany, embryology, poetry, and scientific bibliography. 43 Friedrich August Kekulé von Stradonitz birth. September 7, 1829, Darmstadt, Grand Duchy of Hesse death. July 13, 1896, Bonn, German Empire known for theory of chemical structure, tetravalence of carbon, structure of benzene. Friedrich August Kekulé von Stradonitz was a German organic chemist. From the 1850s until his death, Kekulé was one of the most prominent chemists in Europe, especially in theoretical chemistry. He was the principal founder of the theory of chemical structure, and in particular the Kekulé structure of benzene. 44 Robert Koch birth. December 11, 1843, Clausthal, Hanover now Clausthal-Zellerfeld, Germany death. May 27, 1910, Baden-Baden, Germany known for bacteriology. Robert Heinrich Hermann Koch was a German physician and one of the founders of bacteriology. He discovered the anthrax disease cycle, 1876, and the bacteria responsible for tuberculosis, 1882, and cholera, 1883. For his discoveries in regard to tuberculosis, he received the Nobel Prize for Physiology or Medicine in 1905. 45 Murray Gell-Mann birth. September 15, 1929, Manhattan, New York City, United States known for Gell-Mann and low theorem elementary particles, quarks, Gell-Mann matrices. Murray Gell-Mann was an American physicist, winner of the Nobel Prize for Physics in 1969 for his work pertaining to the classification of subatomic particles and their interactions. 46 Hermann Emil Louis Fischer birth. October 9, 1852, Euskirchen, Rhine province death. July 15, 1919, Berlin, Germany known for organic chemistry. Emil Hermann Fischer was a German chemist who was awarded the 1902 Nobel Prize for Chemistry in recognition of his investigations of the sugar and purine groups of substances. 47 Dmitry Mendeleev birth. January 27, February 8, New Style, 1834, Tobolsk, Siberia, Russian Empire death. January 20th, February 2nd, 1907, St. Petersburg, Russia known for the periodic table of elements. Dmitry Mendeleev was a Russian chemist who developed the periodic classification of the elements. Mendeleev found that, when all the known chemical elements were arranged in order of increasing atomic weight, the resulting table displayed a recurring pattern or periodicity of properties within groups of elements. In his version of the periodic table of 1871, he left gaps in places where he believed unknown elements would find their place. He even predicted the likely properties of 3 of the potential elements. The subsequent proof of many of his predictions within his lifetime brought fame to Mendeleev as the founder of the periodic law. 48 Sheldon Glashow birth. December 5, 1932, New York City, New York, USA known for electroweak theory and Georgy Glashow model. Sheldon Lee Glashow was an American theoretical physicist who, with Stephen Weinberg and Abdus Salam, received the Nobel Prize for Physics in 1979 for their complementary efforts in formulating the electroweak theory, which explains the unity of electromagnetism and the weak force. We are just an advanced breed of monkeys on a minor planet of a very average star. But we can understand the universe. That makes us something very special. A Stephen Hawking radiation is blackbody radiation that is predicted to be released by black holes, due to quantum effects near the black hole event horizon. It is named after the physicist Stephen Hawking, who provided a theoretical argument for its existence in 1974. Black hole temperature is proportional to one black hole mass. Black hole entropy is proportional to area of the event horizon, the highest object at which the natural sciences are constrained to aim, but which they will never reach, is the determination of the forces which are present in nature, and of the state of matter at any given moment. In one word, the reduction of all the phenomena of nature to mechanics. Gustav Robert Kirchhoff. Kirchhoff's junction rule formula. Sum of the currents in and out of a circuit junction equals 0 sigma I equals 0 I equals current, amperes, A. Kirchhoff's loop rule formula. Sum of voltage differences around a circuit loop equals 0 sigma V equals 0 V equals voltage difference, volts, V. During the first half of the present century we had an Alexander von Humboldt, who was able to scan the scientific knowledge of his time in its details, and to bring it within one vast generalization. At the present juncture, it is obviously very doubtful whether this task could be accomplished in a similar way, even by a mind with gifts so peculiarly suited for the purpose as Humboldt's was, and if all his time and work were devoted to the purpose. A Hermann von Helmholtz free energy equals internal energy, absolute temperature times entropy. As long as man continues to be the ruthless destroyer of lower living beings, he will never know health or peace. For as long as men massacre animals, they will kill each other. Indeed, he who sows the seed of murder and pain cannot reap joy and love. Pythagoras theorem. In a right-angled triangle, the square of the hypotenuse side is equal to the sum of squares of the other two sides. Hypotenuse equals square root, perpendicular, 2 plus, base, 2, in the natural sciences, and particularly in chemistry. Generalities must come after the detailed knowledge of each fact and not before it. At Joseph Louis Gay-Lussac's law, the pressure of a given mass of gas varies directly with the absolute temperature of the gas, when the volume is kept constant. Mathematics reveals its secrets only to those who approach it with pure love, for its own beauty. Archimedes' buoyant force equals minus fluid density times acceleration due to gravity times fluid volume. It must be admitted that very simple relations exist between the volumes of gaseous substances and the numbers of simple or compound molecules which form them. The first hypothesis to present itself in this connection, and apparently even the only admissible one, is the supposition that the number of integral molecules in any gases is always the same for equal volumes, or always proportional to the volumes. Indeed, if we were to suppose that the number of molecules contained in a given volume were different for different gases, it would scarcely be possible to conceive that the law regulating the distance of molecules could give in all cases relations so simple as those which the facts just detailed compel us to acknowledge between the volume and the number of molecules. Amedeo Avogadro's law. For a given mass of an ideal gas, the volume and amount, moles, of the gas are directly proportional if the temperature and pressure are constant. Ordinarily, logic is divided into the examination of ideas, judgments, arguments, and methods. The two latter are generally reduced to judgments, that is, arguments are reduced to apodictic judgments that such and such conclusions follow from such and such premises, and method is reduced to judgments that prescribe the procedure that should be followed in the search for truth. André Marie Ampère 49 James Dewey Watson birth, April 6, 1928, Chicago, Illinois, U.S. known for. The structure of DNA. James Dewey Watson was an American geneticist and biophysicist who played a crucial role in the discovery of the molecular structure of deoxyribonucleic acid, DNA, the substance that is the basis of heredity. For this accomplishment he was awarded the 1962 Nobel Prize for Physiology or Medicine with Francis Crick and Maurice Wilkins. 50 John Bardeen birth, May 23, 1908, Madison, Wisconsin, U.S. death, January 30, 1991, Boston, Massachusetts, U.S. known for. Superconductivity and BCS theory. John Bardeen was an American physicist who was co-winner of the Nobel Prize for Physics in both 1956 and 1972. He shared the 1956 prize with William B. Shockley and Walter H. Brattain for their joint invention of the transistor. With Leon N. Cooper and John R. Schrieffer, he was awarded the 1972 prize for development of the theory of superconductivity. Please subscribe us if you like our content. Stay tuned for part 2.